Thank you for joining us for another Digital Dimensions Productivity webcast. Today we're going to be talking about SOLIDWORKS Sustainability. Let's go ahead and get started. Let me make sure you guys can hear my audio here. Alright, let's go ahead and get started. Today we're going to be talking about SOLIDWORKS Sustainability. My name is Enrique Garcia and I'll be presenting sustainability to you guys. So today this is the breakdown of what we're going to be talking about. We're going to be talking about just sustainable design and terminology. About 20 years ago we started to become more environmentally conscious as far as what we do with our environments. A company called PE International was one of the starting companies that offered consulting, and they were based out of Stuttgart, Germany, and they kind of started setting up the bar for us to follow along, and it's become more of a trend. Hopefully it doesn't end up, it's not a phase, and becomes one of these integral parts of our design process. So we're going to talk about just some of the different sustainable design terminology pertinent to SOLIDWORKS sustainability. Also, we're going to speak about the differences between sustainability and sustainability express. There are a couple of key differences that I do want to show for that. Also, although it is quite simple and it's fully integrated into the interface, I want to mention the workflow for using sustainability. I'll show you how to attack this product just using a part file, and then we'll go and do an assembly file, and we'll do we'll show you how to flip-flop between making modifications to the model and going back and checking the environmental impact. And lastly, we're going to go in and just talk about just some troubleshooting, some just technical topics as far as little things and questions you might have for us for this morning. So with SOLIDWORKS sustainability, we do have 4 main environmental impact factors that we talk about. The number one is the carbon footprint. Also, let me just, talk about them here separately. We also have total energy consumed throughout the whole life of the product. Also, air acidification, and this is a precursor basically to acid rain and environmental issues. And lastly, water eutrophication. That's basically putting sewage and extra nutrients that are going to change the effect of your environment. Here's some of the just the terminology here that I want to cover for the purposes of our discussion this morning. LCA, or life cycle assessment, the investigation and evaluation of the environmental impacts to any given product or design. Now, this isn't only for just products. This extends to the macro level as well. Buildings, the governments, all kinds of organizations are getting on this bandwagon, if you will, and they're becoming more earth conscious. And I'm kind of glad this is a new product for SOLIDWORKS in 2010, and we're pretty proud to show it this morning. Also, carbon footprint is basically all of your emissions, or what they call greenhouse gases, that are caused by any building, organization, an event you're putting on, or in our case a product, and it's going to be measured in carbon dioxide, or CO2. Water eutrophication. This is an increase in chemical or nutrients, both in nitrates and excrement or waste, if you will, that will cause just negative environmental effects to your surrounding environment where you operate. And it's measured in PO4 or nitrogen. Air acidification is basically your airborne emissions, sulfur oxide, nitrous oxides that get excreted into the air, based off of product creation. Lastly, total energy consumed. This will be measured in megajoules here in SOLIDWORKS sustainability, and is any non-renewable energy resource or sources that will be used throughout the entire product's life cycle, basically. Let's go ahead and move along here. I want to talk about the differences between sustainability and sustainability express. Now, here's a good little table that sums up the differences. Just these are some of the different features that we have. Like, we can analyze parts, select materials. Now, the main difference between sustainability express and sustainability is the ability to analyze assemblies, support the new assembly visualization tool, which I will cover today as well. It's a great little tool that lets you go in and itemize and kind of critique all of your different parts in your assemblies based on different criteria, whether it be mass, whether it be, in our case, a carbon footprint, or air quality, or total energy measurement. So we can go ahead and itemize all of these and rank them based on all of these different attributes. Also, we do have support for configurations, and we also have the ability to select a transportation type inside of SOLIDWORKS Sustainability. Now let's go in and start talking about the different workflows that we have for both the part level and the assembly level for sustainability. This is just basically a hit list that you want to maybe take a look at when you're going to go in and start to perform an environmental analysis. You want to go in and do what's called a task list. This is if you have an assembly that you haven't specified all of the different materials. Now with sustainability, there is a database set that we've gotten from PE International, and we have all the applicable information from a database that we can apply these environmental studies with. Now, if you've selected a material that doesn't comply with that, sustainability will bring up this task list and will allow you to select a different or similar material to go ahead and go about your sustainability study. So we will show you that task list. Also, we will talk about selecting a manufacturing and transportation for your product and your materials. From then on, we're going to go in and show the interface for showing the environmental impact. After you've seen the initial environmental impact for your model as is, we can set a baseline so we can do some comparative analysis between your initial design and what you can possibly do to help improve your design from a sustainability point of view. We can after we've done checking out and finding the most optimal configuration for this new assembly or design, we can generate a report in Microsoft Word. We can email that out quite easily just from the interface. So let's jump in here and take a look here. I want to open up a model. So cell phone is one of the most disposable items we have in our culture today. So let's say we want a really nice a nice cell phone here. All right, so we have this particular model. Let's go ahead and make it real nice. Let's change up the material, perhaps. Let's take a look at our initial design. So to start up your sustainability product, go ahead and go to the Tools menu. Go to Sustainability. Takes just a little bit of time just to go ahead and take the material and to go ahead and apply the information from the database. Now let's go ahead and just choose an initial material here. Let's go and choose something nice, something trendy that we see. Let's do how about an aluminum? Just to copy the iPhone. Maybe this is something Apple did. And let's choose 1060 is pretty common. Let's choose that and let's set the material. So I will talk about this interface here in just a second. So let me go in. Let's just do it right now. So first off, you want to put in your material. You want to set the material here. This will actually go back to your SOLIDWORKS settings and will apply the material. Currently, we have no material set in our SOLIDWORKS attribute there. So once we've decided on a material, I can hit Set Material, and that will propagate to the part level. Also, we have a Find Similar option, which we will talk about here in a couple of seconds. So currently I've selected a aluminum alloy, a 1060 alloy. I want to go in and choose which process I want to use to create the product, and I'll just choose here as a good list of the different options we have available. I want to choose maybe milled option. Most likely this will be, if this is an Apple product or something, it's going to be created in Foxconn, so we'll go ahead and select Asia for our area of manufacturing, and the transportation of it will majorly be inside the US, and the use of the product will be in the United States. Now from that, SOLIDWORKS in real time will go in and calculate an environmental impact. These are the 4 factors that we've talked about previously. So for a carbon footprint, let's go in and see we have a 1.96 carbon footprint. Energy in megajoules, 24.19, air quality 0.01, and 4.72 e to the 4 for water usage or eutrophication. So the next thing I want to do is set a baseline. So I want to be able to do some comparisons between just different approaches and different materials. So let's go in and select a baseline. So I'm going to go ahead and toggle back on the baseline tool. And you'll see here that we've now cleared the air. We're ready to go in and apply a change and do some more comparisons. Before I go in and make a change, I just want to go in and show this with a little more clarity as far as the environmental impact section. I can click on my next button and I can see a nice breakdown of each individual variable that we're having sustainability analyze. Just go through those to get a good idea of what you're looking at. So again, the black is the baseline and the green is the current configuration. So as we've only set a baseline and have not changed anything, I do expect all of these to be the same level. All right. So now let's make a change. Let's go in and change a material to something that's more, let's say, cheaper to manufacture, easier to take care of, and is a more common material for manufacturing for a phone, and more cost effective. Let's go in. That's something that we have from previous knowledge. Let's go in and change the material to plastic. Any plastic will do. Let's just choose something like a low density. How about this polyether polyol? All right. Once you've done that, you can see that the impact level has significantly dropped down from aluminum to plastic. Now let's see. Let's go ahead and set a new baseline. Let's see if we can find a better material than this polyether polyol. So I want to set a new baseline. So I like where I'm going at. So let's go ahead and toggle on, off, and toggle on the baseline. So now let's select this Find Similar tool from Sustainability. And I can choose for the material class. Maybe I decide to go against plastic and go against maybe the aluminum again, or maybe I want to get super fancy and do a titanium alloy. I can do so. In this case, I want to do a plastic again, and I want to choose maybe a different type of condition I can set. Let's say I want to have, maybe my phone gets quite hot, or you want to take a look at something that conducts thermally a little better, so let me increase that. Let's find something similar. Now I can go in here, and SOLIDWORKS will go through the database supplied by PE International, and I can choose and I can drill down to select more appropriate materials for my list. Let me just pick some randomly here. Let's do a nylon, and let's do good old ABS. Not the best there. Let's do that anyway, and let's do those three. I can click on this filter button. Now I can compare these three specifically. Now what's great about this is I can click on each individual material. SOLIDWORKS will do the calculation for environmental impact for each of the different variables, so I can see and compare with what my baseline was, which was my previous material, my polyether polyol, compared to, in this case, ABS. So we do see a small, maybe a significant decrease there. Let's see what nylon looks like. Not so good, so let's keep on going there. Let's choose PPE. Water eutrophication is a little better. Air is better. Energy, it takes a little bit more energy, non-renewable energy to supply that. So let's go up, let's indulge everyone. Let's do ABS. We'll not worry about the air so much, just to show that we can change this. I want to hit accept. Now this goes ahead and shows my impact area here, and if I'm okay with this, I want to hit the set material, and this will actually change my material to ABS. Now at this point, let me see if you guys have any questions for us. Alright, we'll go ahead and continue on. Alright, so let's continue on. So now we're able to see and set the material. Also, one thing I failed to show, once we do a find similar, and I choose something that's similar, let me go ahead and do plastic once again. Let me do a find similar. Also, if I decide to change my mind on any of the conditions I set for finding the material, I can go back to the edit button and I can choose that particular option and then go back find similar. Also, if you're going between, let's say, aluminum and you're going to plastic, you can change the manufacturing process on the fly with the interface here to reflect the appropriate process. Alright, let's show how you can change the actual physicality of the model, and just by removing material, you can actually increase or decrease the environmental impact of your sustainability study. So let's say that this model is a pretty high-end plastic, or maybe we're back at the aluminum type of material, and I want to actually make it very heavy and make the build quality really, really well. So I want to have a nice thick material, but that will also increase the environmental impact of the product. So let's go in and let's shell out the model, or at least remove some of the material so it's a little lighter. Maybe you don't like a big lead weight in your pocket when you're walking down the street. You want something light, something functional, and also in the end will increase your environmental impact. So I'm just going to go ahead and apply just a nice little cut here to remove some of the material on the inside. You can also apply this with a shell and whatnot. So the next thing you'll see is that we want to update. After we've changed our geometry, we're going to click the section here to update the equation and have it resolve the equation. Now you can see here that our environmental impact has decreased just slightly, a little bit more. Also, let me go back and let me change it to how it was and set my baseline to see exactly how much. So I'm going to go back and set a baseline. Now I'm going to apply my removal of my excess material, and all I'm doing is just cutting down the middle of this part, nothing significant. So if I just show my cross section and show you what I'm doing here, I'm just basically removing weight and excess material to the model. Now we have a cavity, and let me update. So from that previous baseline, we've I think cut down significantly on the environmental impact. So you want to do this back and forth, modify your materials, modify your geometry until you get the most appropriate or satisfactory environmental impact results. So after you're done, let's go ahead and create and generate a nice report. What's great about this report here is the little icon for generate a report. Also, if it doesn't say generate report, that means that you've probably already created a report, and we're just going to go ahead and modify the results on that report. Let me click on that, and we're going to generate one for us here. Now, what's nice about these reports, these can be put into a design history file, any of your life cycle documentation for creating your product. Alright, I think we're done. Now, let's take a look at what we have. So what's nice about this is that it's ready to be edited. You can put in your company logo, and this is actually being pulled from a template, and I'll show you where that's at a little bit later in the webcast. So let's take a look at what we have. This is our initial design. We chose an ABS plastic for this. These are our sustainability results and the 4 environmental impacts that we've chosen. What's nice is it breaks them down into material, manufacturing, actual usage, and the end of life, or disposable, or the way, or the ability to dispose of your product, and how it affects the environment. Now here's our baseline, which is the ABS plastic. Nice little graphic there. Now here's our final configuration that we've chosen. And again, this goes in and shows your comparisons, and it breaks them down into these 4 subsections. At the end here, just a graphic, and also there's a glossary, which is quite nice. This way you can have it for your documentation. But that is the workflow for a part level sustainability study. Let me go in and show you what you can do for an assembly. It gets a little more interesting with an assembly. Let me close this down. Alright, let's continue on. Alright, let's go ahead and let me close this model and let me open up, first off, just a model I've never opened using sustainability, so I can show what that looks like. Let's see here. Alright, so I have this universal joint assembly here that I like to play around with sometimes. And let's go in and turn on the sustainability tool. Also, you'll notice I actually went in and docked the task pane just because we're going to be using the sustainability tool, and it can be a pain in the neck if you have it undocked, and it just tends to hide. So I always like to pin it down when I'm doing sustainability analysis. Let's go in and go to Tools, Sustainability. Now, even though the sustainability tool is an add-in, it's actually not located inside of the tools add-in section. Now, I will show you how to set this all up a little later, but just thought I'd point that out, that it's actually located under the tools menu, sustainability. Alright, so first off, I want to go ahead and pin down the sustainability or the task pane. And I want to show you the task list. The task list, you'll notice in my design tree, if I expand some of these, I don't have a material selected for any one of these components. So if the software does not see a database for a material that's recognized by sustainability, or if you have none selected at all, it will give you this interface to allow you to select a material for each individual part file. So let's just go ahead and put a couple of them in there. Let's do steel. Carbon steel. Notice how we have check marks after I can exclude one if I want to. And notice the interface change here. So I've excluded the yoke male for whatever reason. Maybe it's a significantly high, or you don't want it in your study for whatever reason. I can exclude that. Also, I can re-include that later, and I can use this maybe as a baseline. Maybe I have an important part that's an integral piece of my model, and I want to show why it's important to have it in there, even though it does affect the environment in this way. I can make a case for it. So you want to go ahead and do this. You can actually, I haven't checked this, but let's see if you can select multiple parts, and it looks like you can, which is a nice little feature. All right, let's continue on. So we do have the ability to go in and do a multi-select. So that's the interface. So I want to go in and open up another model here to walk through. You'll notice here we have the same interface. Let me go ahead and back out of this and open up another model. I want to show you how we can change a model design with simulation as well. Let me open up this little humidifier model I found. So again, we'll turn on sustainability. Now, one thing I want to mention with the sustainability, when I go to the tools menu and I click on sustainability for the very first time, it will actually wait a little bit longer to load up sustainability. Now, I can only speculate as to why this is happening. Maybe it's a first revision of the software, or what I'm thinking is happening is that it's going to each individual part and it's actually looking for all of the information. Notice how now it finally came up now, and it's doing its calculation. So I think it has to compile all the data, and it's just taking a little longer for it to load up. Notice for the part file, it didn't take long at all. Give it a minute here to finish its initial calculation. Now if I take a look here, if I click on each of these different individual parts, you'll notice that it does show up your actual model design, design name, and it shows you the actual material that's selected. And these are all materials that have been pre-selected that are inside of the models. And what I've actually done was I've selected a group of them, or each individual one, and I've selected the material from here. I've done a set material. This way I can ensure myself that I'm using PE International's certified materials for my analysis. So let's take a look here. Let's go in and apply the location of the manufacturing, which is Asia. Now this is what I've mentioned that's shown in the assembly level, which is the ability to pick a transportation method. Now let me just show you the impact you have with all these different modes of transportation. Let me set a quick baseline here. And the baseline was using train as the majority means of transportation. Now I want to pick something that's significantly more expensive. Let's do aircraft. I'll pick plane. You should see a nice significant increase in red to show the impact in the environment. Let me just pick another one here. I'll pick by boat. Alright, so let's go ahead and leave it back to train. And now before I continue on, let me do a quick reset of the baseline here. And I want to show you the assembly visualization tool. Now like I mentioned before, the assembly visualization tool is something that was added in 2010 SOLIDWORKS. Also, we've added a new tab in 2010. It's called the Evaluate tab. This is a great place to apply and out of the box, it comes with all of these different interrogation tools that you can apply to your models just to find more information. Amongst them, you'll find sustainability. So this is an additional place to start up sustainability, or Sustainability Express. Now let me click on the Assembly Visualization tool. Now what this will do, by default, it's set to mass, and it will actually itemize all of your models according to what the mass is of the model. Now this will still work if you haven't selected a material. The reason for that is we have in our options menu, we have the ability to choose a default mass. So if you have a larger volume, you'll have a higher mass. So you can go in and you can actually change up. If I double click, I can change the color of what the low end of the spectrum is for that. Let me cancel that. And let me go in and just click and drag this so you can see. It's an easier way to kind of take a look at what is significant and what is insignificant in terms of mass in this case. Also, I can shut off these little nice bars, which is a good little visual eye candy and a good way of seeing what's going on as well. Supplies good information. Let's go in and change the criteria. Let's go in and analyze this based on something that's more pertinent to what we're looking at. Let's change this to carbon footprint. So let's choose sustainability carbon. Now you can see the materials that take up the most carbon to be in existence is going to be the top cover, which is the one highlighted in light blue, also the underbase, and lastly the tank, or the water tank. For this, this is a humidifier. Also, if you want to choose additional attributes to go and itemize from, I can click on this little flyout, and I can go down and I can choose more. And I can have a full listing of all the different attributes that I can itemize with. Maybe I'm more interested in, oh, I don't know, let's do air. So that slightly changes the things. But that's the assembly visualization tool, and what's nice is I can from there on go in and change things and have it update and keep an eye on what is important based off of all of my parts. Any questions so far? All right, let's continue on here. Let's go in and do a simulation study. Let's go in and choose this tank part, and let's assume, since this is a humidifier, this is something that's in someone's household being used. I think it's safe to say that we need to figure out to see if maybe a book can be placed on top of this, or maybe a coffee cup, just in case something were to happen. Some sort of a reasonable force, compression force perhaps, or just a downward normal force. So we can see, so we can give this thing maybe a safety factor. I want to say a safety factor of 2 would be okay for this application. So this way we can incorporate a simulation with sustainability, so we can get the best possible combination. Let me open up this tank part. And I want to click to update here, and I want to set a baseline. Let me set my baseline, toggle off and toggle back on. The material is set to PMMA, and we're doing injection molding. We're doing manufactured in Asia. So let's run a simulation study. So I have a study already preset for us, and let me just go over it quickly to show you what, so we're all on the same page. Basically, we're trying to figure out, we've basically fixed this model at the base here, just to simulate it being on the actual machine. We've applied a 50 Newton force in the downward direction, just to kind of simulate putting a book or something on top of the tank area. And we've also simulated pressure pushing on the insides of this tank wall to simulate having some sort of water or liquid inside of the humidifier. So let me run my study. And we're going to take a look at the factor of safety that we get from this force that we put on. Now, again, the goal here is that it's going to be at least a factor of safety of 2. So let's see what we have. So I think we're doing pretty darn good. We're getting a factor of safety of 9.61, which is significantly higher. So we've basically over-engineered this as it stands. So let's take a look at the environmental impact on this. So we noticed before with our baselines what we have. So let's see if we can improve on our design. Let's change the material. Let's do plastic, and let's go in and just choose, let's do like a very low density poly, and let's see what we get. So I can also change the process. In this case, we're not doing too bad. The only thing that we do see a significant decrease is the amount of air that we're going to soil based off of creating this part. So now, once we've done that, I want to go in and I want to see if, with using this material, how will my factor of safety be affected. So a good way of going between sustainability and simulation is actually going over to the model here real quick, clicking on the model so I can see my model features. And I want to go in and notice how my material is still PMMA. I want to go back to the sustainability. I want to click on set material, and this will actually change my material over to what I've selected now, which is the very low density PE. Now with that selected inside of my model, I want to go back and update my assembly. And you'll notice here, because sustainability, SOLIDWORKS, and simulation work hand in hand, this is also updated my material as well. And I want to go in and update components and rerun the study. Any questions while I'm running the study here? Alright, let's continue on. So this is our stress, our displacement plot. We're currently interested in the factor of safety. So we've chosen a new material that's a little more environmentally friendly, and we've only sacrificed about four, or actually three units of factor of safety, which is not bad, since we're still above our two units of factor of safety. So we've actually still over-engineered the part. So there's still much to be done. We can go in and we can actually change the thickness of the tank. Let's go in and keep this going. Let's go in and reset our baseline. I'm pretty happy with this. We're going to, for now, use this very low density. Also, if you want to keep on cycling through all your different materials, you can hit Find Similar, and you can optimize your material, just like we saw earlier. So let's change up our baseline, and let's go in and just do some more changes here. Let's go to the model now, and I want to maybe change the shell. Let's go and change that a little bit. So our thickness here for our shell, let's change that to maybe 1.5 millimeters. So again, we're removing material. Maybe do a rebuild. Again, rebuild will also cause the environmental impact calculation to reoccur. There it is. We see a change there. Actually, let's see. So that's significantly less as well. So we're still improving on this model. Now let's make sure that our study, we're going to update our geometry here as well. We're going to rerun with the new thickness on the shell and see what our factor of safety is. So the bottom line is you want to keep on doing this. It's a step, a methodical process you'll go through until you're satisfied with a factor of safety or a criteria that you've been looking at. Let me say no. I think I may have reached the limit there of my model. Let's check out the factor of safety. We're still okay. So I did not do a large displacement mode. I may be reaching the limit of where I want. So I'm actually doing pretty good there. 2.46 factor of safety. So this is probably as optimized as I want. So at the end of this, let's go back to our overall assembly. So just because we are a fully associative software, if I go back to my model, it will do the update for you. There's the feedback. And again, it's doing the calculation with the new geometry and the new part material. So overall, it takes a little more energy, but we've definitely increased the environmental impact just slightly, and we did not significantly decrease the amount of energy used. So I think that may be a good trade-off. So in the end, after we're done doing our comparisons, let's go in and generate a report. Now there's nothing we can do here. It's just a matter of waiting for the calculation to finish. And let's go check out our report. There's a humidifier. Again, initial environmental impact. Now this is what makes this stand out based on, from the part level, is we have the three major components that contribute to the environmental impact and the three components that contribute least to the environmental impact. A good little visual representing the ones in red are the ones that are significantly affecting it. The ones in green are the ones that are affecting the impact the least. And again, just the end here with the glossary. Going back to SOLIDWORKS, just to kind of show you what else you can do as far as exporting, you can go in and you can send the report out, and if you click on this, it'll open your native email client and will automatically attach this report. It will generate it if you haven't done so, and we'll send it out for you. Also, we have the ability to import a baseline. Now this is great. Let's say you've worked on a product before and you really like the way that it was set up. You want to reuse that on this new product. All you have to do is open up the new product, go in and navigate for the other product that you'd like, and it has to be a SOLIDWORKS file, and you can click open and that will automatically populate whatever attributes you have set for that. Also, we have a little online information area just to kind of spread the word for sustainable design. So I'll let you guys explore that at a later date. All right, just some of the different topics I want to talk about as some of the things that we're not that we're missing there with sustainability is that you're not able to actually choose the parameters for transportation or manufacturing from the actual study there. So you have to choose it. It's either all or nothing for every single part file. It's not an individual basis. Also, one of the things you can't do is you cannot create custom materials to include in the study. The reasoning behind this is because we have PE International's database, and they're the ones that consult with us, and they give us all the information for this database. So we currently don't have the ability to go in and create our own materials and populate them with our own variables and information for the solver to evaluate with. Also, sustainability is it's a separate product like flow simulation. If you want to go ahead and do an add-in from it, you have to go in and reactivate your product to get the sustainability add-in. Let me show you what I mean here. So if you have not purchased a license for sustainability yet, if you go into the tools menu, you will see it say Sustainability Express. Now let's say you go in and you purchase a seat for sustainability, the full product. What you need to do is you need to go into the help menu. You need to go over and you need to select Activate License. Just like you would do this for the SOLIDWORKS process, you want to go in and select your product is going to be SOLIDWORKS. You're going to say automatically over the internet. You're going to hit next a couple of times. It's going to go in and ping the server. It's going to see that you do have a new license for sustainability. It's going to go ahead and activate that for you. Let me cancel this. After you're done doing that, you can check to make sure that it's in there. SOLIDWORKS will actually bring up this window, but this Show Licenses from the Help menu will come up, and you'll see when your sustainability product is actually expires, or when the subscription is expired. So once you have that in there, and all it is, it's not a question of modifying your installation or anything heavy duty like you would with simulation or you would with PDM Works. This is all is installed. All we're doing is unlocking these extra capabilities for the full sustainability product. Other things I want to mention here is the templates location. When I go in and I generate a report, SOLIDWORKS pulls this report off of a template. Now you can go in and modify this to put maybe more graphics that are more towards your liking, or maybe more company logos to make it more customizable. To go to that template location, it's going to be located under your SOLIDWORKS installation directory. Which is under here, Program Files, and let's go in and choose SOLIDWORKS Corp, SOLIDWORKS, Lang, English, and there are actually two templates in here. One is for assemblies and one is for the part document, and they are DOT files. So let me take a look here. They are called Sustainability. Here they are. Sustainability Assembly Report is for the assembly, and Sustainability Report is for a part file. Now, when you go in and you do modify these, make sure you do not change the extension. Make sure they remain as a DOT file, or else it won't work with simulation, or it won't work with sustainability, excuse me. One other thing I want to mention with sustainability is that it's not a standalone product at all. It is something that is you do need to have SOLIDWORKS to run and maintain. As far as what you've seen is inside of, I don't know if you guys check out SOLIDWORKS Labs. We do have a Sustainability Express section in there. That's meant for SOLIDWORKS 2009 only. So if you do have 2008, there's no need to go in there and pick that. But if you are on a previous major release, such as 2009, and you don't have sustainability yet, you can go in and download that from labs.solidworks.com and be able to use this product, or the Express version. Also, for all the students out there, we do have the sustainability product inside of the educational version for the 2010-2011 release. If you have the 09-010 version still, you do need to go to that SOLIDWORKS Labs download to get that. So that is available for students as well. Other things I want to point out is at the part level, we are missing the transportation, which should be included with our sustainability product. So we should be able to see a transportation option in here, so we can select that. Currently, it's not able to be selected inside of our material, but it's not able to be selected inside of the part file. All right, I think that's everything I have for us this morning. I want to thank you guys for joining me this morning and talking about sustainability. We will go ahead and archive this webcast at a later date if you guys want to review it for at a later time. That's going to be located on our website, which is www.ddicad.com. Also, if you're interested in being more involved and getting more information from our DDI community and the CAD industry community, feel free to follow us here at Twitter, which is twitter.com/DDICAD, and DDICAD is our handle. We have a Facebook fan page as well for all you Facebookers out there. Also YouTube. YouTube, we have small little tech tips, maybe a minute or two, just short enough to get some good information and move on with your work. Also, we have Lou Gallo's website. It's a podcast and blog site for the CAD and new technologies related to CAD and SolidWorks called SolidWorksHerd.com. Also, part of that is we have a blog that's associated with that. It's called The Herd, and that's located at herd.solidworksherd.com. And again, I'd like to thank you for joining us this morning.